Good morning, everybody. Thanks, Stephen. I'll try and get through all the things you mentioned, and hopefully I don't leave anything out. Some interesting questions coming through the chat as well. Um, this is the team, so I want to thank all of these guys because they're the ones who put all this data together, and some of them have actually worked through the holiday period to produce this report 3 months earlier than usual. If anyone has any queries after the presentations or any time at all, that's the email address to contact the team. Yeah, what I'm going to basically go through is most of the long-term trends and then try and capture what's happening in the biggest sectors. I may not get to all of these sectors, but I'll certainly cover the main sectors. The slides will be available afterwards in case I don't get to the end. These are the annual emission trends. Stephen just showed a shorter version of this, and what we can really see is the growth in the early part of the 1990s to 2000, with sustained increases almost every year. And then the recession is quite evident after 2006 to 2007, and then into the 2 years where we had the economic crash. And now we're seeing, COVID in 2020 and this rebound post-COVID. It's interesting to note that the actual increase this year is the largest increase we ever had in the 32-year time series. And it isn't all rebound emissions, as Stephen says. Transport certainly rebounded, but we had some exceptional growth in cement and electricity generation that wouldn't really have been impacted too much by COVID in 2020. This is the trend excluding LULUCF and the sectoral shares. You can see agriculture is the biggest sector, and we have the other two large sectors, which is transport and energy industries. And when you include LULUCF, we have this blue sector at the top. The shares of the other sectors decline, but this is about 7 million tons with LULUCF. And if you can see in the profiles for 2021, excluding LULUCF, we have 61.5 million tons. We have 37.5% from agriculture, 17.7% from transport, and nearly 17% from energy industries. But when we add in LULUCF, this 11.2% share of the 69.3 million tons, most of the main sectors, as you see, drop down to a third, less than 15%, and just over 15%. Historically, we would have only spoken about this side of the slide and not this side, but now our climate targets nationally include LULUCF, so we'll be speaking more about this from now on. This is the relative trend of emissions over time. It peaked at 29% above 1990 in the middle part of the Celtic Tiger years, and now it's 11.4% above 1990. And I just compared that with gross GNI, gross national income. I believe there's a GNI star now, which is a bit modified, so maybe next year we'll talk about that. But you can see there was a decoupling kind of from the economic growth of the country and emissions, and you can see the recession is evident here, and then COVID is evident here. But you can see that gap has narrowed slightly this year as emissions increase again. This is per capita emissions across the EU member states. I don't have 2021 data. As I said, we're going to upload this 2021 data to the Commission by the 31st of July, and then other countries will do likewise. So that data will be available, I suppose, the day afterwards on the 1st of August. But just to say, this year, last year's 2020 was 11.8 tons per person in Ireland, and you can see we're the third highest in the European Union. If you just looked at CO2, we'd be 7 tons per person, which would put us somewhere between Estonia and Finland. But really the issue for Ireland, its profile, is the methane and the N2O. No country has 3.4 tons per capita of methane emissions, and nobody else has 1.2 tons of N2O emissions per person either. I mean, I think Denmark's the nearest, and Denmark is 1.4 tons per person of methane. If you look at then the time series, population has grown from 3.5 million to 5 million now in 2021, and the CSO just published their preliminary results of the census back in April, and population now is 5.1 million. And you can see here we had a peak of per capita emissions of 18 back into 1999, 1998, and we had an all-time low last year during COVID of less than 12, and we'll come back up again in 2021. Just to say, like, I mean, projected population is going to be 5.5 million 2030, 5.9 million 2040, and 6.2 million by 2050. So this is the time period we're talking about decarbonising the economy and getting to climate neutral by 2050. But for every additional 1 million people, that's putting on a pressure of, at current levels, 11 to 12 million tonnes per annum. So we really need to reduce our per capita emission, because all of these people, the additional people, will need housing, they'll need transport, they'll need to have electricity, and they'll generate waste. So it's very important that we start to decarbonise all of these sectors. Now we'll just talk about agriculture. Stephen's already shown a lot of these slides, but you know, it's interesting to note there's not too many decreases in agriculture in the last 10 years. There was a peak back in 98, and now we're at the all-time high again in 2021. Previously that 2018 was the all-time high. But you can see in the last 10 years, there was only a reduction in 2014 and a reduction in 2019. So certainly emissions are increasing in this sector. And you can see the driver here is actually methane, and this has gone up for 10 consecutive years. And I'll discuss that again in a little bit. And if you want to look at agriculture by gas, you can see in 1990 it was 67% methane, 26% N2O, and 6% CO2. And that profile has changed slightly. So now we have a 19% increase in methane from 1990 to 2021. We had a 6% increase in N2O for the same period, and we had an 8% increase in CO2 over the same 32-year period. And most of this is driven by enteric fermentation, which is up 18% over the 32 years, and manure management, which has both methane and N2O, and that's up 30% over the 32 years. And the drivers for this, we'll just show the dairy herd first, and the dairy herd was 1.34 million animals back in 1990. And it kind of bottomed out, you know, during the period 2005 to 2010, and we've had increase in dairy herd for the last 11 years. When you overlay that with milk production, you can see milk production was, you know, stable at around 5 billion litres per annum, but now it's increased to almost 9 billion litres since the removal of quotas. Which is a really significant increase. And when I show the next slide, the pressures that puts on the amount of greenhouse gas emissions. And if you look at the cattle populations, this is the relative index for dairy cattle in blue. And it was, if we say 100 is the baseline 1990, we're now 16% higher in 2021. So that really is 134 million animals going to almost 1.6 million animals. And there was a 44% increase in this 11-year, 10-year period. When you add in the other cattle, I mean, it really hasn't dipped below 1990 levels, except in 2010. And that may have been to do with the recession back in the global economic recession back at the time. But you can still see now we've 6% more other cattle than we had in 1990. And to compound that, what happens is that each of these cattle are emitting more and more emissions each year. In 1990, a dairy cow emitted 114 kilograms of methane between enteric fermentation and manure management. And in 2021, it's now 133 kilograms of methane. And just to put that in context, 133 kilograms of methane is 3.7 tons of CO2 equivalent. And when I show you another slide later on, that's exactly the emissions from a house. So we've nearly 2 million houses and we've 1.6 million dairy cows. So they each produce around 7 million tons of CO2 equivalent. And just to say that the projection for 2030 for a dairy cow will be 139 kilos per animal. And the projection by 2040 could be 147 kilos per animal, given the current situation. And then when we look at other cattle, they emit less. These cover like the suckler herd, beef animals, and quite different levels of immature animals under 1 year old, 1 to 2 years old, etc. And these emit about 46 kilograms in 1990, and now it's 53 in 2021. So that's an 11% increase per animal as well. And again, the context of that would be about 1.5 tons of CO2 per animal.
5 minutes, Paul.
Okay, so I'll just skip through. These are just the trends in agricultural, other agricultural drivers. I mean, you can see all of them are up, and the notes will be in the slide. Poultry's up, pigs are up, sheep are up in the last 10 years, and you can see that this one here is poultry is up 60% on 1990. Just to get on to transport, Stephen's showed this already, but maybe I'll get to the drivers is really the fuel. Petrol was at an all-time low in 2020, and now it's gone up again in 2021. Diesel is back at 90% of pre-COVID levels, and biofuels save about 500,000 tons per annum. And over the 15 years that we've had biofuels, they've saved about 5 million tons. We look at the vehicles, and you can see we have some BEVs coming in here. That's about 2% of battery electric vehicles, or including hybrids. But you can see the growth in diesel cars over the 30-year period, and then the decline of petrol vehicles. This is what's with additional measures in the climate plan, was to have 40-odd thousand battery electric and plug-in hybrids, and we've actually gone ahead of that in 2021, even though we've less BEVs and more PHEVs than planned in the target. Somebody put a question about international aviation. You can see, yes, international aviation, when it's an EU to an EU flight, is actually an ETS. So all of our flights with our European neighbours are in the emissions trading scheme. It's only the flights to the Far East, China, South America, and the US, they're not in the ETS. You can see the COVID pandemic, but we all know what's happening now in global air travel. So we expect to see 2022 numbers back up close to 3 million tons again. And this is National Maritime Navigation, just to say this wasn't impacted by COVID, and it's responsible for about 500,000 tons each year. And this sector will be going into ETS within the EU shortly in the next few years. I say Stephen's already talked about the energy industries and the intensity. The intensity has gone up by 12% since last year. And I think the next slide really shows why. You can see here the coal and the peat was at an all-time low in 2020, and now we've more coal and oil. And you can see gas went from 51% to 46%, and renewables dropped from 42%, which was an all-time high, to less than 35%. It's interesting to note we also imported, quite a bit of electricity last year, and if we had made that electricity in Ireland, it would have increased emissions by another 500,000 tons. This is the effect of, this is coal and peat and electricity share over the 30-year time period, and the CO2 from that. So you can see a 5% share of the electricity produces a quarter of emissions, and this year went up to 9%, and it's a third of the emissions. So these, coal and peat is really, really carbon intensive. This is the relative trend of electricity consumption. We can see emissions are lower than 1990, but we're using 150% more electricity. Residential, Stephen showed this, so I'll just say this is the profile of the number of households increasing over the 30 years and the tons of emissions per household. And this is what I'm saying, each household now is about 3.8 tons per household, which is, as I said, like a dairy cow, and it was 3.5 tons back in 2014. That's the heating profile. You can see it was a warmer winter. There's less heating than the blue line, the red and the blue. You can have a look at that. The cement sector comes up. This is very important. So increase in cement was 450,000 tons last year. And, you know, emissions are now, you know, 18% above, sorry, yeah, the 18% increase. And you can see that 2007 was the peak, and then we had the economic recession, and now, but this wasn't really impacted COVID. They had a longer shutdown in 2020, but they seemed to up production after the restrictions.
You're at your 11:50 now, Paul.
Okay, I'll just have 2 more slides. This is the power gen. This is ETS profile, where we had 22 million in 2005, and now we've 15 million in 2021. So that's a 31% reduction. But this is a big increase in the ETS in 1 year. 15% is the biggest increase ever. You can look at that, and I'll just skip to the drivers for landfill gases. This is the savings of 30 million tons of landfill gas over the last 16 to 20 years, and that's reduced our emissions that we would have emitted if we hadn't had utilization and flaring of landfills. I'm just going to skip on to the end then, Mary Frances, and just say, as Stephen said, all of the stuff is available on the web, and the report is available to download. And there's about 5 or 6 additional slides here which people can download after the conference and have a look. Thank you.